I was promised that there was going to be like smoke and lasers, but the music is perfect. Thrilled to be here with all of you. Thrilled to be here at the Norrsken Foundation, which is really just doing such amazing work. And particularly thrilled to be here as part of LEAPS and in collaboration with LEAPS, because we are at a leap moment in our world. And we are leaping forward in our technology. And if we leap forward in our technology, and we don't leap forward in our ethics and values and public engagement, this wonderful story of possibility will become a terrible story of dysfunction, fear, and anger. So I'm going to talk to you tonight about science. But really, science is just what brings us to the beginning of the conversation, because this is a conversation about ethics. We are here about ethics. The question isn't science, yes or no. We know the answer, science, yes. The question is how best. And the answer to how best our technologies can be used is up to all of us. And that's why we're here, and that's why these kinds of dialogues are so important. But we are leaping forward, and the reason that we are leaping forward is we are at this moment of exponential change. People throw that word around, but what does it mean? It means that right now we have more people who are literate and educated than pretty much at any point in the entire history of our species. As a matter of fact, maybe 20 years ago, we got to the point where right now there are more people educated and literate than everyone on Earth combined through the entire history of human evolution until about 20 or 30 years ago. And it's not just that we have all of this brain power, it's that people are connected to each other through these incredible networks. There were different parts of the world, and sorry I'm speaking fast, but this 10 minutes and all this energy pushes me forward. There were different parts of the world that came up with the recipe for bronze and copper 1, 2, 3,000 years apart. And that means that if you are 3,000 years later than some other civilization in coming up with bronze, all of the things you can do with bronze don't happen for that period of time. Today, if somebody comes up with the recipe for bronze or anything else, you know what you do? You just post it. You send an email, you write a paper, and then everybody else on Earth now has it. So put that in the bronze example. Now you're 3,000 years ahead in developmental time than you otherwise would have been. And that's in everything, in every area. And so we are racing forward, and we have these different names for technologies as if they are in silos. We have computer science and machine learning and AI and genetics and biotech and nanotech and quantum. And it's confusing because that's not really what's happening. What we're seeing is a super convergence of technologies, that the computer science revolution makes the machine learning and AI revolution possible, which unlocks the secret of biology, and then biological design feeds back into all of those other areas. And it's this loop of technologies leaning against each other and driving change ever forward on this exponential J-curve. And it's moving so fast, but it's also accelerating. And because of that, because it's accelerating, our sense of time, based on the way our brains are designed for evolutionary purposes, our sense of time looking forward, if we benchmark it based on the rate of change looking backwards, is going to be too conservative and too slow. So we all need to really open up our minds. I write nonfiction, but I also am a science fiction writer. And one of the reasons why I like science fiction is it allows us to step outside of ourselves and imagine a different future. But everybody needs to think like a science fiction writer, like a futurist, to be able to fathom what is coming and how quickly it is going to get here. Because the limit on what is possible is in many cases just our own imagination. And our own imagination is in many ways limitless, especially when there are so many of us thinking and working and collaborating together. And that is going to open up a whole new set of possibilities in every area of endeavor. Max is going to talk about AI, which is, again, it's one of these enabling technologies that is going to touch pretty much everything else. My area is genetics and biotech. And basically what we are recognizing, the key realization of this moment in our history, is that our biology and all of biology is as readable, writable, and hackable as our information technology. And it's this crazy thought that this little group of hominins who climbed down from the trees in Africa, who biologically aren't that different from our cousins, the bonobos and the chimpanzees, all of a sudden we have access and we have developed these tools to remake all of life on Earth, including our own. And that's exciting and it's scary. And you have to have both feelings or you're going to be missing something. And the genetics revolution is not some far-off sci-fi fiction. It is happening right now, and there are 3 key areas where we are already experiencing it and will continue to do so. The first one, and we have what was on the slides a moment ago, and what Bayer and others are working on, is this fundamental transformation of healthcare. And we are moving from a world of generalized medicine based on population averages, where you go to a doctor and in most cases you get treated based on the fact that you're a human, based on averages, to a world of precision or personalized medicine, where your treatments will be tailored to your own individual biology. And so your doctor, when prescribing some kind of treatment, is going to want and need to know who you are as an individual. And how are they going to do that? Through your electronic health and life records, through your personal history, your family history, your sensors, but the most important piece of your health record and the important foundation of your treatment will be your sequenced genome. And most people will have their genome sequenced immediately after birth or before birth. So we are very, very quickly moving to a world where we will have millions. We now have millions, but tens, hundreds of millions, and then within a decade, up to 2 billion people who have had their whole genome sequenced. And then we will have these massive data sets of genotypic, genetic, and phenotypic information, and we will use that to unlock the secrets of complex genetics and complex systems biology more broadly. And that will transition us from this world of precision healthcare to predictive healthcare. And what that means is from the moment just after or before your birth, your parents and then you will know about your range of possibility in many different areas. And part of that will be healthcare. And it will be great to know that your child has, for example, an increased risk of getting type 2 diabetes or breast cancer, because you can think about testing earlier and lifestyle changes. And this will really help us move toward where we have to move toward a predictive model of healthcare. But we don't have a disease genome or a healthcare genome. We have a human genome. And so this genetic information is going to tell us many things about who and what we are, have at least the range of possibility to be, including areas of traits like height, complex genetic traits, height, genetic component of personality style, genetic components of IQ. And we are really touching some of these core foundations of what it means to be a human being. And then in the area of assisted reproduction, we're going to use and are already using this technology to sequence pre-implanted embryos, and then with a process that exists all over the world, including here, of selecting among these pre-implanted embryos, called pre-implantation genetic testing, based on a genetic understanding of possibility, and then using gene editing tools like CRISPR, and now this week there's a new tool better than CRISPR called prime editing, to edit the genomes of pre-implanted human embryos. And this will be done both to eliminate harms and to provide benefits, and there will be no clear boundary between those two things. So this is racing forward. And it's racing forward in a context of us, where we humans, we're very different within societies and between societies, and we are very competitive, both within and between societies. When you look at a country like China, they have these core technologies that they are seeing as the foundation for building their competitive edge. And the application of genetics and biotech is certainly one of those. And this raises fundamental ethical questions, issues like, how do we think about interfering with complex biological systems we don't fully understand. Equity, who has access to these technologies. And diversity, which is not a nice to have. Diversity is the sole survival strategy of our species. And if we want to live in a world where the benefits, the incredible benefits of these technologies are optimized and the harms are minimized, we can't just leave it up to governments. We can't just leave it up to experts. This is up to all of us. And that means everybody needs to be educated. Everybody needs to be part of the conversation. Everybody needs to be empowered. And we need to group together to say, we want our elected officials to focus on these issues. And we want to begin to develop norms for making sure that our most cherished values guide the application of our most powerful technologies. Thank you.
Amazing.